Alright, welcome back to Inorganic TUTOR'S Institute. In today's tutorial, we are basically going to solve 20 multiple problems in Advanced Calculus 1 that will enhance our understanding towards our quiz in the coming days. Okay, so basically, our vision is very broad, is to develop a world-class educational institute that integrate STEM programs and business-related programs into a unified environment for the modern students. As you know, we are employing tutors from various expert fields. As usual, data analysis is already in session. We are having actuarial science, we are having statistics, economics, to begin in early January of 2026. So you know what? Anticipate. And one thing you do to help us to build this dream to the highest level for the whole world to see us is to subscribe, share, and like. Do comments, and I really appreciate that. Please don't forget to subscribe. I love that. So you know what? Okay, so our first problem is we want to evaluate this particular limit. All right, limit as s plus y, absolute of s plus y approaches infinity of this particular expression. Right now, if I'm to leave you, you can easily do this, right? But I want you to get a basic concept why we are going to do certain things before we proceed. Okay, so basically for any large number for this thing, right? For any large s plus y, absolute of s plus y, the quadratic terms, okay? The quadratic terms will dominate. You know why? Because of the degrees. The quadratic terms will dominate. The s squared plus y squared will dominate. So basically what we are going to do is to divide both numerator and denominator by x squared plus y squared, just like the highest power of s and y, right? So what we do is that we divide the numerator and the denominator by the highest power of x and y, which is s squared plus y squared. Okay, so we're going to have limit as s plus y, absolute of that, approaches infinity, s squared plus y squared, divided by s squared plus y squared. That is the numerator. Or divided by x divided by s squared plus y squared plus s squared plus y squared divided by s squared plus y squared, right? So we divided both numerator and denominator by the term, the quadratic term, which will dominate the more, right? So when we do that, you're going to have limit as absolute x plus y approaches infinity. You know, this will basically give us 1, right? The numerator will end up giving us 1. Divided by this right here, we are going to have x divided by x plus s squared plus y squared, okay, plus this right here will give us 1. So we have plus 1, okay, and then basically it reduces to 1 over, you know, this right here will approach infinity. You know why? As I said from the beginning, absolute of s plus y will will be very large. For any large number, absolute of s plus y will be very large. Let me come again. For any large number s plus y, absolute of that, the quadratic terms will dominate. Meaning, when we put infinity here, and you know that anything over infinity is what? 0. So you're going to have 0, that is x divided by infinity, right? Plus 1. And that will be equal to 1 over 0 plus 1. Okay? And that will basically yield x infinity 1 over 1, and that is equal to limit as s up of 1. And you know that limit of a constant is the same constant, right? So we have our final answer to be 1. Okay? So the result for evaluating this particular limit is equal to 1. Very, very simple, right? Okay, now give me some very short break. I'll come back for question number 2. Okay, so welcome back from the short break. I believe you have been able to digest the very first question and you are cool with it. I believe you agree that the answer is 1, right? Okay, now let's move on to question number 2. So with question number 2, we want to find the limit of this particular expression and see if it exists or not, right? So limit as s comma y approaches 0 and 0 of this particular expression, okay, s squared over x squared plus y squared. All right, now this we can see here. If we try to use limits along different paths, you realize that the limit will not exist, right? So let's try that and see. So let's try to use along y equals 0, the expression will basically produce 1. If you use y equals 0, you realize that the expression will produce 1. See that? You have limit as s comma y approaches 0, 0, and along y equals 0, you're going to have x squared divided by s squared plus what? 0 squared. And that will give us x squared divided by s squared. And you know that this will cancel this, and we have limit as s comma y approaches 0, 0. We have 1, right? So that is when, and you know that limit of a constant is what? The same constant. So along y equals 0, we have the result to be what? 1. Now let's try along x equals 0 and see if we'll get the same result. If we get the same result, then it means the limit what? Exists. But if we don't get the same result, then it means the limit does not what? Exist. So along x equals 0, let's try to see what it will give us. S comma y as it approaches 0, 0. Now x is 0, right? So we substitute 0 there. We have 0 squared divided by 0 squared plus y squared, right? And you know that 0 here will give us 0. 0 over anything is 0. Whatever it is 0. So we have 0 over y squared, of which is what? 0. Now, we can see that along y equals 0, we had 1. And along x equals 0, we had what? 0. So it means that both parts are producing different results, right? So we can boldly say that the limit does not exist. The limit does not exist. Limit does not exist. Limit does not exist. So this particular limit does not exist. As easy as that. The limit does not exist. We used along y equals 0, it gives us 1. Along s equals 0, it gives us 0. That is enough for us to conclude that the limit does not exist. Give me some short break. I'll be back with question number 3. Alright, welcome back from the short break. I believe that you have been able to digest the very second question and you completely agree with me that the solution of this particular limit does not exist, right? So the limit does not exist, right? Okay, now let's look at problem number 3. We have been given this particular function of these two variables, x and y. Okay, that is 1 over s squared minus y squared. And we want to find the domain of this particular function or this particular expression. So what do we do? You know, if you want to find the domain, you check this, right? So for us to get the domain, we have to make sure that the denominator does not go to 0. From our basic school, we know that if you want to get the domain, then it means that the expression must not be undefined, right? So we say that for the domain x squared minus y squared must not be what? 0. So that is the basic thing you have to know about this. Okay, x squared minus y squared must not be 0 from here. Okay, so once we have that, then you know that this, we can either say that x squared must not be equal to y squared, or y squared must not be equal to what? S squared, right? It's either this or that, right? So per the options we have so this is going to be the domain of the function f. The domain of the function f is equal to x comma y that are in real numbers. You know, r squared means x, two real numbers. So x and y, they will be r squared. If it is only x, it will be r. If it is only y, it will be r. But x comma y will be r squared. So x comma y, that belongs to real numbers, r squared, is such that x must not be equal to y, right? S must not be equal to plus or minus y. S must not be equal to plus or minus y. So the solution of this particular thing is going to be, this is the same as S must not be equal to plus or minus y, or if you don't see that, you see y must not be equal to plus or minus x. Alright, so it's either this or that, but per the options we have this, right? We have this. So our solution is x comma y belonging to r squared is such that x must not be equal to plus or minus y. And you know why? If x is equal to plus or minus y, then it means this both x and y have the same items or have the same values. And if they have the same values, then it means that this thing is going to be undefined. And for domain, it must not be undefined for us to get a proper domain, or for us to get a domain, right? So that is question number 3. Give me some short break. I'll be back with question number 4. All right, so welcome back from the short break. I believe you have been able to go through the problem number 3 and you're good with it. All right, so now let's look at problem number 4. You have been given an expression, right? That given that there is a functional relationship. There is a functional relationship between you given this expression and then given this expression. Now, we want to find the relationship, all right? We want to find the relationship. So, first of all, let's write our expression down. U equals sine inverse of x plus sine inverse of y. And that of v is x, 1 minus y squared plus y square root of 1 minus what? S squared. All right. So basically what we have to know in this problem is that you know that sine of u is equal to, note, sine of u is basically equal to sine into arc sine of x, right? Plus arc sine of y. Okay, sine of u is basically equal to sine into arc sine of x plus arc sine of y. So if you see sine inverse of a particular function is the same as arc sine of that particular function, right? So it's the same idea that we are using here. Now, once we know that this is equal to this, then we can say that, we can also say that that will be equal to x, right? X times the square root of 1 minus y squared, right? So that will be equal to x times square root of 1 minus y squared, okay? Plus y times 1 minus s squared. All right? So if you understand this, that is it for all. All right? So basically we can say that this is equal to what? V from the question. This is equal to what? V. All right? That is equal to V from the question. Okay. So we can say that V minus, we can say that V minus sine of u must give us 0. You know why? We said that sine of u is equal to this plus this, right? And that is equal to x times sine, x times square root of 1 minus y squared plus y times square root of 1 minus s squared. And that was given as what? V. So if this is equal to this, and that expression is equal to this, and this is equal to this, then we can say that V minus sine u is equal to what? 0. You know why we are saying that? Because this is V here, we just bring it to the right hand side, becomes negative, and we equate it to what? 0. So that is the relationship among these two expressions. V minus sine of u will be equal to what? 0. So that is the relationship. So V minus sine u will be equal to 0. So that is the relationship among these two expressions. Okay, so note that if you have these two expressions, the relationship among the two is V minus sine u equals 0. V minus sine u equals 0. All you have to know is that sine u is equal to sine into arc sine of x plus arc sine of y. So if you know this information, then realize that this information is equal to the V, and you represent the expression for the V by its denoted variable, which is the V. So if the whole of this is equal to the whole of this, and the whole of this is equal to that, then we can say that V minus sine of u is that, and that should be equal to 0. So we have this expression as the relationship among the u and the V. So that is question number 4. Give me a short break. I'll be back with question number 5. Alright, welcome back from the short break. I believe you have been able to digest the question number 4 and you are good with it. You completely agree with me that the relationship is V minus sine u equals 0, right? Okay, now let's look at question number 5. The question says this is basically an epsilon delta definition problem, but this is not we are not going to show any workings. They have already defined the terms for us. They want us to just tell them something, right? So they're saying that if given epsilon, right, that is greater than 0, positive, there exists delta that is also greater than 0, such that this expression, absolute of s1 of f of s1, comma y1 minus f of s2, comma y2 is less than what? Epsilon. Whenever x1, comma y1 and s2, comma y2 is in the domain of f and 0 less than the square root of this expression is less than what? Delta. Then the function is what? Now, I want to explain this to the lowest point so that everybody will get it. So basically, this question, what it's trying to tell you is that they have given you epsilon, right? They are saying that for every epsilon, it must be positive, right? And if it is positive, then there exists delta that is also what? Positive, right? Such that this expression, right, f of s1, comma sy1 minus f of s2, y2 is less than what? Epsilon. Okay, now we want to know that whenever s1, y1 and s2, y2 is in the domain of the function f and 0 less than this expression is less than what? Delta, then we can say that the function is what? Uniformly continuous. Why is it uniformly continuous? The function is uniformly continuous because delta here, okay, delta here depends only, can you put it there? Delta here depends only on what? Epsilon. Okay, delta here depends only on epsilon. So we cannot say it is continuous, but we can also only say it is uniformly continuous, right? Uniformly, because we don't know whether it is depending on the variable a or b or c. So we can say that it's uniformly continuous on this particular function. So the answer to this particular problem is, so let me complete. Whenever s comma y, s1 comma y1 and s2 comma y2 of the function f and 0 less than square root of s1 s2 plus y1 y2, right, is less than delta, then we can say that the function is uniformly continuous because delta here does not depend on any variable. It only depends on what? Epsilon. So since it only depends on epsilon, we can say that the function is uniformly continuous. Uniformly continuous. So hence the function is uniformly continuous. Uniformly continuous because delta depends solely on what? Epsilon. So we can say that the function is uniformly continuous. And that is question number 5. Give me a very short break. I'll be very... Okay, so with question number 6, you can see that if you read the question number 6 very well, it says that if epsilon is greater than 0, then there is this delta that is also greater than 0, such that this expression f of x comma y minus f of a comma b is less than what? Epsilon. Now, whenever s and y is in the domain of the function f, and 0 is less than this expression, and that is less than what? Delta. Then the function is what? Right? Now, the only difference here is that in here, we don't know whether the function is depending on a and b, or the function is depending on b and c. So that is why we said it is uniformly continuous. So the focus is on the definition of the preamble. So in here, we don't know whether the function is depending on a and b or depending on b and c, right? So we say that the function is uniformly continuous, or delta is, because delta is depending on what? Epsilon only, we say that the function is uniformly continuous. But when it comes to question 6, you can see that delta here is depending on a and b, right? It is not depending on epsilon alone, right? So we can see the definition f of x comma y minus f of a comma b is less than what? Epsilon. So we can see that in here we don't have x1, y1, y2, x2, y2. It's instead x and y minus y, f of a and b. So this here, the function is continuous at the points a and b. You know why? The definition, this is basically the definition of uniform continuity. So this is basically, this is the definition of, this is the definition of definition of continuity at the points A and B, right? So this question defines the continuity at the points A and B, as we can see here, A and B, right? So we can say that the function is continuous on the point or at the point A and B. So the function is continuous at A, B. So continuous at A and B. So that is for question number 6. So once you get a question number 5 correctly, you have to get a question number 6 correct, right? So if you don't see any variable, let's say A, B, or C or something, it's uniformly continuous, right? But if you see a variable A and B, then it means the function or delta does not depend only on epsilon. And that will be the definition of a continuous function or continuity at the points A and B. And that is for this. I believe you enjoyed this so well. Okay, give me some short break. I'll be back with question number 7. Welcome back from the short break. I believe you have been able to digest the 5th and the 6th question and you're good with it. Okay, now let's look at question number 7. We are asked to find the distance between these 2 points. Alright, now this is in 3 spaces, right? X, Y, and Z. So as usual, you know the formula for 2 points when you are asked to find the distance between 2 points when you are in XY SY plane, right? Now it is XYZ. So what you have to do is just extend the formula, right? So you know that distance of this will be equal to square root of x minus x1, or s minus s1 all squared plus y minus y1 all squared plus z minus z1, right? So just have to identify your terms and you're good to go, right? So this is our s1, this is our y1, this is our z1, right? This is our s2 or our x, and this is our y, and this is our z. So we just substitute them and then we are good to go. All right, so what we are going to do is to just substitute them and simplify. Okay, so when we do that, we're going to have x, y, z equals square root of x is 4 minus 2 plus y is minus 2 and y1 is 4, so minus 4 plus z is minus 3 minus 6, so it will be plus 6 all squared. So we're going to have 4 minus 2 is 2, so we have 2 squared plus minus 2 minus 4 minus 6, so we have minus 6 all squared plus minus 3 plus 6, that is positive 3, so we have positive 3 squared, right? So we simplify this. This will give us 4 plus this will give us 36. This will give us 9. All right. So when you sum these 3 digits, you're going to have 49, right? 49. So you have square root of 49. Okay. You have square root of 49. Okay. So you know that square root of 49 is 7. So the distance between this A and B is 7 units, or 7, or you can simply say 7, right? So the distance between these 2 points is 7 units, or you can simply say 7. I believe you enjoyed this. Very easy. Okay. Now let's move on to question number 8. Okay. So with question number 8, we have been given this definition, okay, that f of x and y is equal to sy plus 6x. Then f of x and y is equal to sy plus 6x is continuous, okay, at the point 1 and 2. If given epsilon greater than 0, there exists delta that depends on epsilon of 1 and 2 greater than 0, such that for absolute of x minus 1 less than delta, it means this is a limit. All right. So if you are to write the question well, you write it limit as xy approaches 1 and 2 of the function xy plus what? 6x, right? That's why they are saying that delta that depends on epsilon is greater than 0 of these numbers is greater than 0, such that x minus 1 is less than delta, and y minus 2 is also less than delta. Then we have this expression less than epsilon. So if we choose delta to be what value will make this be exist, right? So how do we do that? What delta are we going to choose for this particular function or this particular limit to exist? So first of all, we have been given the function, right? We have been given the function to be xy plus 6x, right? Now we want to find, or we want to bound, what we want to do is to bound f of x and y minus f of 1 and 2, right? That should be what? Less than epsilon. So what we want to do is to bound, we want to bound f of x and y minus f of what? 1 and 2. And that should be less than epsilon. Right. Now, what we are going to do is to go through each step by step, as we do always. So now xy minus 6x, absolute of that, sy, right, sy plus 6x, right, minus 8, okay, minus 8 will help us. We are going to choose a limit of 8, and that will help us to get the delta, right? So this expression minus 8 will give us the limit to be to exist, right? So this particular expression, okay, the limit is 8. So if you are to write it well, you write it this way: 1 and 2 of xy plus 6x equals 8. And then they will ask you to use epsilon delta definition, right? So the limit L is 8. That is what I've placed there. Okay. Right. So once we have this, then we can rewrite this expression and factor out the needful ones. So we can say that we have x minus 1 plus x minus 1 and y minus 2, right? So we have xy plus 6x minus 8, and that to be equal to xy minus 2 plus 6 into x minus 1. Okay, so when you expand this, you get back to this. What we are trying to do is, epsilon delta definition, once you are able to define your terms, the rest is to manipulate the expression so that you get your delta, so that the function or the limit will exist. Okay, so we are going to have x into y minus 2 plus 2 into x minus 1, okay, plus 6 into x minus 1. Okay, we have not done anything to this expression. We just introduce another term that when you expand this and you expand this, it will cancel out, right? So we are going to have x into y minus 2 plus 8 into x minus 1 . Yeah, you see, we have this in the same coefficient, right? So we take one of this and we add the coefficient. So we have x into y minus 2 plus 8 into x minus 1. Okay, so now we can say that we have f of x and y minus 8 to be less or equal to absolute of x and then absolute of y minus 2, right? This expression is less or equal to absolute of x times absolute of y minus 2. This here, we have introduced the inequality sign. Okay, so plus this 8 into x minus 1, absolute of that. Okay, so we can choose a value, right? We can choose a value for delta. So we can choose delta to be less or equal to 1. We can choose delta to be less or equal to 1. So we're going to have then x minus 1, absolute of that will be less than 1, right? S minus 1, absolute of that will be less than what? 1. And that will imply that absolute of x is less or equal to absolute of what? X minus 1 plus 1. Okay, and that is less than 2. So that is for x minus 1, absolute of that, it will be less than what? 8. And then we can say that y minus 2 is less than delta. So it follows that f of x and y minus 8, absolute of that result must be less or equal to 2 delta plus 8. Right? Yes, 2 delta plus 8 delta. And this will basically give us 10 delta. Alright, so we have delta here to be, this expression to be equal to what? 10 delta. So now to make the sign less than epsilon, what we have to do is we have to choose a number, right? A suffix that will be able to cancel the 10. So to make this less than epsilon, then its surface to pick, we are picking something like 10, right? Yes, we are picking 10, and that will take off that. So if we pick 10, then we can say that our delta is epsilon over what? 10, right? So that is our delta. Okay, so if we do this, then it means we are still keeping what? Epsilon, we are still keeping delta to be what? Less or equal to 1. If we pick this number, then it means we are still keeping delta to be what? Less or equal to 1. So a safe choice will be a minimum of 1 and also this value. So a better choice for us will be delta to be equal to a minimum of 1, and also this particular value, epsilon over 10. So this will be the delta that we will have to choose for us to be able to get that particular limit right. Okay, so that is question number 8. Give me some short break. I'll be right back with question number 9. Okay, welcome back from the short break. I believe you have been able to digest question number 8 and you are good with it. Now let's look at question number 9. Question number 9 says that what should be f of 1 and 2 if the function, this particular function, equals this? What should be f of 1 and 2 if the function this is equal to this 3xy, if f of x and y is not equal to 1 and 2, 0 if x and y is equal to 1 and 2. Well, what should be f of 1 and 2? So basically this question, what is demanding from us is to check what will make the function continuous, right? So to be continuous at 1 and 2, we basically need the limits as x and y approaches 1 and 2 of 3xy, all right, of 3xy equals f of 1 and 2, right? That's the limits is lim as xy approaches 1 and 2 of 3xy equals 3 into what? You see, this we are going to use what? Direct substitution. So we put 1 here times 2, right? And this will give us 6. Okay, so hence to make f continuous, you must set f of 1 and 2 to be what? 6. So hence to make f continuous, we must set the limits, right? We must set f of 1 and 2 to positive 6, and that will be fine for us. So f of 1 and 2 must be equal to what? 6. And that will be our final answer for question number 9. Okay, so we move on to question number 10. Welcome back from the short break. Now this is question number 10. All right, you have been given this particular limit, right? You have been given this particular limit, and we want to find the limit to that, right? We want to find this limit. We want to find this particular limit. Okay, so first of all, we have to look at the problem. Okay, study the problem, know the procedure that you are going to use. So in this context, we have to use the polar, right? The polar, because we have x squared plus y squared over x squared plus y squared. Okay, so we have to use the polar. Okay, so using the polar, all right, using the polar, we are going to say that r squared should be equal to what? X squared plus what? Y squared, right? That is the polar form. Okay, so we know that x is equal to r cos theta, right? If x is equal to r cos theta, then we can now say that now the expression becomes r limit as sy approaches 0, 0 of s now is r cos theta, right? So r cos theta, and we know that we've said that x squared plus y squared should be what? R squared. So we are going to have sine into r squared divided by r squared. Okay, so if you simplify this, you're going to have limits as x and y approaches 0, 0. This will take one of this. So we have cos theta times sine into what? R squared divided by R. Okay, so this is what we have now. And you know that so far as R approaches 0, in here you are going to have 0, right? And you know, sine R squared will basically approach will be approximately R squared. So as R approaches 0, sine R squared will be approximately R squared. So we're going to have sine into R squared divided by R to be producing what? A result of 0. Okay, so basically we can say that this whole expression will give us 0. The whole of this expression, the limit is what? 0. So the whole product, so the limit of that, so the whole product is 0. So the limit of this is equal to 0. So if you see an information of this sort, you have to use the polar coordinates, right? And that gives us 0. That is question number 10. Now let's brief a little bit and come back for question number 11. Okay, welcome back from the short break. Now, with question number 11, we are to determine the set of points for which h of x and y is equal to exponential of x over y is continuous. Okay, so basically this question is trying to tell us it's asking us to check the continuity, right? So basically what we are going to do is that we are going to check this. Okay, now note that x over y is defined, right? X over y is defined. So note, x over y is defined, right? X over y is defined, and thus the exponential is exactly when y is not 0. Now on that open set, the composition of continuous function is continuous. So therefore all values of x and y with y not equal to 0, we can say that the sets x and y such that y is not 0 is valid. Okay, the set x and y such that y is not 0 is valid. Okay, so for this to be okay, or for this to be defined, x over y is alright defined, okay, but for it to be exactly, for the exponential to be exactly, then y must not be 0. If y is 0, we have distorted the definition. So y must not be 0, then we are good to go. So with basically that particular question, h is continuous on the set. So h is continuous. H is continuous on the set. H is continuous on the set x comma y, given that or such that y is not what? 0. Such that y is not 0. So that is the basic information you have to know about this question number 11. All right, now let's move on to question number. So with question number 12, we are basically, the question is asking us to find the range, okay? The range of this function is what? Okay, so for you to get the range, it must satisfy this condition. The inner function, right? The inside function, all right? 16 minus x squared minus y squared minus z squared must be greater or equal to what? 0. Remember, any expression under a square root sign must be positive, right? Must be either equal to 0 or more. All right. So once it satisfies that condition, then you can move on. So you know that the square root returns non-negative values. Okay, the square root returns non-negative values, and it's basically maximum. Its maximum, right? Its maximum value is what? 4. Okay, so the square root returns non-negative values, and its maximum is square root of what? 16, and that is equal to what? 4. From this, the maximum it can go is square root of 16, which is what? 4. So we can say that the range lies between 0 of the function and 4. Right, so this is the range. Okay, so we can restate it as record. Okay, so thus the function t is such that 0 is less than or equal to t less than or equal to what? 4. And that is the range to this particular function. All right, that is the range to this particular function. So if you don't see this, then you see this. I basically replace the f of x, y, and z by t. So they are all the same. So the range for this particular disk is 0 less than or equal to f of x, y, z, less than or equal to what? 4. So that is the range for this. That is very simple, right? Now let's come back shortly for question number 13. Question number 13, we want to describe the set of points represented by the domain of this expression. Now, what is the domain of that expression? Laying into 9 minus x squared minus y squared. What is the domain? You know, one interesting thing about logarithm or natural log is that it does not accept a negative value. Okay, so anything inside a natural log function must be greater than 0. It must be greater than 0, strictly greater than 0. Okay, strictly greater than 0. So inside the natural log must be positive, right? Inside the natural log, it must be what? Positive. So 9 minus x squared minus y squared must be what? Positive. Okay, so once we have that, we can now say that x squared plus y squared must be what? Less than 9, because we change the position, right? Once you change this to this, right, the sign changes to what? Less than, and this becomes positive. Okay, now once we have this, how are we going to describe this particular data that we have? Okay, so that is the open disk of radius 3. You know, it's r squared, right? The expression itself is something plus this r squared. So if this is 9, then it means that our radius is what? 3. So that is the open disk of radius, the open disk of radius 3, excluding the boundary, excluding the boundary. Therefore, points in the circle, for x squared plus y squared less than what? 9. So we are taking, this is basically describing a circle excluding the boundary. It's describing a circle excluding the boundary. Okay, this particular function is describing a circle excluding the boundary. Okay, so let's write it here. Let's write the description here. Okay, so the description, okay, this is describing a set of points, in a circle, excluding points on the boundary. Excluding points on the boundary. So this particular function is describing a set of points in a circle excluding points on the boundary. So we don't include points on the boundary. All right, and that will describe this particular function. Okay, so that is question number 13. Let's move on to question number 14. With question number 14, we are asked to, the question is basically demanding us to find the domain of this particular function, all right? And you know that for you to have, if you're having a natural log function, anything inside the natural log function must be what? Positive, that is greater than 0. So this expression 9 minus x squared minus y squared must be what? Positive. Okay, and you know that this will give us x squared plus y squared less than 9, right? So this, when you divide through by 9, you're going to have 9 here, 9 here, 9, and this will take off this. We have x squared over 9 plus y squared over 9 less than 1. But you know that this expression y squared over 9 is basically equal to y squared times 1 over 9, right? And this, we can say that it is equivalent to x squared over 9, x squared over 9 plus y squared less than 1. So this becomes the domain of this particular function. That becomes the domain of that particular function. So let me write the answer here boldly for you. So you can see that question 13 and question 14 are like. They are likewise, right? They are almost the same. So the domain of that particular function is domain of f is equal to x comma y x squared over 9 plus y squared less than positive 1, right? And that becomes the domain of this particular expression. So it's either you have it this way, or you have it this way, or that way. They are all correct. So this is equivalent to this. Okay, so the domain of that is this. So that is question number 14. Give me some short break. I'll be back with question number 15. Welcome back from the short break. This is question number 15, and you want to find the domain of this sine inverse of this expression, right? Now, one thing I want you to note is that if you have sine inverse, okay, sine inverse is basically defined. Any argument in the sine inverse is defined when you have this, the arc sine restricted on a boundary, -1 and +1. You know, sine itself lies between -1 and +1. So note, arc sine is defined. Arc sine is defined when its argument lies in -1 and +1, right? Okay, so we're going to have -1 less than or equal to, this is the argument, so s plus y minus 1 less than or equal to positive 1. Okay, so we can equally write this as minus 1 less than or equal to s plus y less than or equal to 2, right? Yeah, plus 1 here, so we have 0. So we have 0 less than or equal to s plus y less than or equal to 2. So it's either you see this solution or you see this solution. Okay, it's either you see this solution or you see this solution. So if you see this, it means directly the argument in the arc-sine function must lie between -1 and +1. So we have -1 less than or equal to s plus y minus 1 less than or equal to 1. Or when you simplify it, you're going to get 0 less than or equal to s plus y less than or equal to +2. So that is the domain for this particular arc-sine. Okay, so that is question number 15. Let's move on to question number 16. Okay, so with question number 16, we are to evaluate this particular limit, all right? S squared sine y over s z squared plus 4, okay? And x, y, z approaches 2, pi on 2, 0. Okay, so you know what? This is a direct substitution limit problem, okay? So we're just going to substitute the values of x, y, and z into the expression, and then we get the value of the limits, right? So we have limits as x, y, z approaches these values 2, pi on 2, and 0. We are going to have 2 squared sine pi on 2 divided by z is 0, so 0 squared plus 4. So we're going to have 4 sine into pi on 2 divided by 0 squared plus 4, and that is 4, right? So you can see that this cancels this, so we have sine into pi on 2. And we all know that sine into pi on 2 is basically 1, right? Sine into pi on 2 is basically 1. So you know pi is 180. 180 divided by 2 is basically 90, right? And sine 90 is 1. Sine 90 is 1, okay? So you're going to have sine 90, right? And that is equal to +1. So when you evaluate this, you're going to get +1. That is question number 16. I believe it's so interesting, right? Let's come back for question number 17. Okay, so with question number 17, we have been given this particular problem, okay, this particular limit. We want to evaluate. So what we do is that we have to check the expression first, if it is factorizable, right? And this particular problem, you can see that we have two operators at the denominator. So we can rationalize, right? So we have this divided by square root of that, square root of this, times square root of x plus 2 square root of y divided by square root of x plus 2 square root of y. So this we are going to have, when you multiply the numerator, you're going to have xy minus 4y squared multiplied by square root of x plus 2 square root of y divided by square root of x minus 2 square root of y times square root of x plus 2 square root of what? Y. So we can see that y is common to this term, right? So we factor y out and we have x minus 4y times square root of x plus 2 square root of y divided by, when you factorize this, you expand this and you see that some terms will be cancelling out. So when you do that nicely, you're going to have s plus 2 square root of xy minus 2 square root of xy minus 4y. Okay, and that we are going to have y into x minus 4y square root of x plus 2 square root of y divided by, this will take off this and then we have x minus 4y. Okay, now we can see that this right here can cancel this as well and we have y into square root of x plus square root of 2 times square root of y. Okay, now you can see that this particular function is now linear and so we can do direct substitution. Now look at the limit. The limit is 0, 0. Y is 0, s 0. So we put 0 here. We have 0 here, square root of 0 plus 2 square root of 0. So basically we're going to have 0 into 0 plus 0. And this is what? 0. Okay? So the limit of this particular expression is 0. Okay? But when you look in your book, you realize that at some of the years, they used 4 and 1. When you use 4 and 1 here, the result will be 4. Okay? The results will be 4. But in this case, the limit is what? 0, 0. So when you evaluate it, you're going to have what? 0. And that is it for this particular problem. Okay, let's move on to question number. Okay, with question number 18, we want to find the domain of this particular function. All right, so what we need to do is to make sure the expression under the square root sign, the denominator must not be what? Must not be negative, or the expression under the square root sign must be positive, right? So we say that this x squared plus y squared must be greater or equal to, must be greater than 0, right? You know why we are saying it must be greater than 0? If it is equal to 0, it means that the denominator will be what? 0, and anything over 0 is what? Undefined. So the denominator here must be what? Greater than 0. Okay? Now, if that is greater than 0, then you know that if it is greater than 0, right? If it is greater than 0, then we can say that except at 0, 0, because if we accept 0, 0, if we accept 0, 0, the fraction, as I said earlier, the fraction is undefined. The fraction is undefined at 0, 0, right? This one will be undefined at 0, 0. So we don't allow the denominator to be equal to what? 0. It must be greater than 0. Okay, so since the denominator is positive, okay, that is away from the origin, then the domain is giving us, the domain of G will be giving us, x and y such that x, y is greater than or equal to 0, right? You know, I'm using backslash because we are excluding what? 0. X, y greater or equal to what? 0. We are excluding what? 0. That's why it's backslash. Alright? So we can equally write it as s comma y such that sy is greater. Okay, so that is question number 18. All right, that is question number 18. So you can see that the denominator here must not be 0. If the denominator is 0, this expression will be what? Undefined. All right, so we make sure that the denominator does not include 0, and that will make the function defined. All right, so that is the solution for question number 18. That is the solution for question number 18. Right? Yes. So we are not including 0. If you include 0, the function will be what? Undefined. So we don't include 0. We say that it must be greater than 0. Or we say that s and y must be what? Must exclude 0 and 0. So s and y must not be equal to 0, 0. And that will make the function defined. And then we can have our domain. Alright, so that is question number 18. Now let's move on to question number 19. This particular expression, you know, this question is just like question number 9. Okay, they said what should be f of 1 and 2 if the function f of x and y is equal to this, right? Now they have given you the function, right? And so they are asking you that what will be the function if this expression is to be continuous at 1 and 2. So what you just have to do is to do what? Substitute, right? Because this is a direct expression. It's not anything of fraction or something, right? So this is just like question number 9. So we're going to do limit as x, y approaches 1 and 2 of 2xy must be equal to 2 into what? 1 into 2. And that is what? 4. Right? So for this particular function to be continuous at 1 and 2, it must produce a limit of what? 4. Right? So the value is what? 4. The value is 4. And that is it for question number 19. Very, very simple. Very, very simple as A, B, C, D. Okay, so we move on to question number 20. All right, we move on to question number 20, and that will be our last problem for the day. Okay, so question number 20, you give me some short break, I'll be back with question number 20. With question number 20, which is going to be our last question for the day, we want to evaluate this particular limit, okay? And this particular limit, I'm going to use Taylor or series to evaluate it. So what I'm going to do is to let square root of 1 plus t equals 1 plus t over 2, right? So 1 plus t should be equal to 1 plus t over 2, right? So once I have that, that is series or Taylor expansion, Taylor series expansion, right? So that is plus 0 of t. Okay, so with this we are going to have square root of 1 plus square root of t, 1 plus square root of 1 plus s squared minus 1 minus that. Okay, and this is approximately equal to 1 plus s squared divided by 2 minus 1 minus y squared divided by 2, right? And that's when we divide by the s squared plus y squared, we are going to have when we divide by s squared plus y squared, we are going to have 1 on 2, and that is equal to 0.5. So this particular problem, I actually use Taylor expansion to get the answer. All right, so the limit, when you evaluate this, you're going to have 0.5 or half. All right, and that is the limit of this particular function. Wow, that is so impressive. You have done a lot, and I believe that you have learned a lot, and I wish you the very best in your quiz on Sunday. May the God be with you. Please don't forget to subscribe, share with your mates, and remember to comment as well. And one time I'll take my time and I'll structure the course on the channel for our own good at our comfortable time. Thank you very much for watching. Have a good time. Bye bye.